Okay, this is Taylor Polynomials 1, example 1. We're going to find the cubic Taylor polynomial for f of x equals 1 over x squared, centered at x equals 2. Okay, from page 1 of the Notes and Learning Goals, you see that the cubic Taylor polynomial, the general cubic Taylor polynomial, is okay, where this is centered at c, centered at x equals 2, so that tells us that in this example c is equal to 2. Right. So we can go ahead and put those in. Let's say a0 plus a1 x minus 2 plus a2 x minus 2 squared, a cubed, or a3, sorry, not a cubed, a3 x minus c cubed. Okay. All right, so now we got to figure out these ANs. All right, from the bottom of the last page, we have a formula for those. Okay, I know it seems like kind of a weird formula. We'll be able to derive this formula later after we get to Taylor series. Okay, all right. So in this case, remember we found it's centered at this c is the center. We were told to find the Taylor polynomial at the cubic Taylor polynomial at center 2. So we can replace that c with a 2. All right, this notation fn, let's see. So let's say when you put a little 2 there, this is f double prime. So it means 2 primes. So f3, 2 is f1, 2, 3. Third derivative at 2. Okay. All right, so we're going to need to compute all the way up to a3. So a3, we have a little 3 there, so up to the third derivative. Okay, so we might as well write out f0 of x. This is just f of x, which is 1 over x squared. And now we might as well set up to take multiple derivatives, so I'll write it as x to the negative 2. Okay, so let me move this over here. Let's say f of x is x to the negative 2. All right, so f prime of x, we've got negative 2x to the negative 2 minus 1, that's negative 3. F double prime, negative 2 times negative 3. X to the negative 3 minus 1 is negative 4. And f triple prime of x is negative 2, negative 3, negative 4, x negative 4 minus 1 is negative 5. Let's see, let's check our work. Let's see, we got f of x was x to the negative 2. Brought down the negative 2, decrement by 1, so negative 2 minus 1, negative 3. Okay, we brought that down there. Negative 3 minus 1 is negative 4. Brought that down. Negative 4 minus 1 is negative 5. Okay. So let's see, this is 1 over x squared. This is -2 over x cubed. This is positive 6 over x to the 4th. Okay, we found this was 6, right? 6 times 4, so negative 24 over x to the 5th. Let me write that using the notation. So of x, 1 of x, 2 of x, and 3 of x. And I'll just give myself a little more room here. We've got 1 over x squared -2 over x cubed (6 over x to the 4th) -24 over x to the 5th. Okay, now for the formula, right, we want to evaluate at 2. So we've got so 1 over 2 squared, 1/4. 2 over 2 cubed, you can think of it as 2 over 8, or just remember that you can cancel those there. This would be a -1/4. 6 over 2 to the 4th. 6 is 3 times 2. 2 to the 4th. Cancel one of those. Left with, one of those over 3. So we have 3 over 2 cubed, so 3 over 8. 3 over 8. Making sure, noticing the negatives alternate, so positive, negative, positive, negative. Checking my work that way, saying, okay, let's say I got a negative there, positive, negative, positive, okay. So I know I'm doing something right. -24 over 2 to the 5th. Let's see, 24. 8 times 3. 8 is 2 cubed, so we got 2 cubed. 3 times 2 cubed. Squared. -3/4. Let's see, times 3/4, and then to the 5th. Okay. Okay. So remember our formula. An is nth derivative at c over n factorial. C in our case is 2. So A0 is f0 at 2 over 0 factorial. Remember, 0 factorial is 1. Found that to be a 4th, so we have a 4th. A1, f1 of 2 over 1 factorial. Let's see, f1 of 2 we found to be negative a 4th over 1. 1 factorial is 1, so we had negative a 4th. All right, so we can put that stuff in here now. Let's see, A0 was 1/4. A1, negative 1/4. A2, G factorial is 2 times 1, otherwise known as 2. F2, we have 3/8. 2/1, so this is 3/8 times 1/2. So that is 3/16. So A2 is 3/16. Three factorial. 3 factorial is 3 times 2 times 1, otherwise known as 6. F3 of 2 we found to be negative 3/4. Put a little 1 there. Do the flip up rule. You got negative 3/4 times 1/6. So 2 times, so we've got negative 1/8. And that is our answer.